Hello, welcome to this introduction video about A-Level Computer Science. My name is Paul Bates and I'm the Head of Computing at St Peter's Catholic School. In this video I'm going to cover the following. 1. Why you should study computer science. 2. What you will study during the course. 3. How you will be formally assessed. 4. What grades you need to be eligible to study computer science. 5. What other subjects students study alongside computer science. And 6. What our students have done after their A-Level studies. Computers have changed the world. Thanks to the work of prominent computer scientists such as Alan Turing, John von Neumann, Grace Hopper, Margaret Hamilton, as well as the more recent contributions of Bill Gates, Paul Allen, Steve Jobs, Steve Wozniak and Sir Tim Berners-Lee, we are able to communicate, collaborate and tackle the challenges of the 21st century. Whether it is our home lives, work, education, staying connected, or just having access to the right information at the right time, computer science is the linchpin. Agriculture, conservation, education, engineering, healthcare, transportation, tourism and utilities are just some of the industries that are benefiting from the developments in computing in the last 10 years. However, while there are millions of consumers of the technology, what we still need are more people with the knowledge, skills and abilities to meet the demands that we will face in the future. Organisations want computer scientists to develop the solutions they need and continually push the technology further. We delivered the AQA A-Level specification, which is made up of these 13 areas of study. Programming is a big part of studying computer science, and we use Python as our programming language. We start with improving our understanding of procedural programming and move on to developing object-oriented programming skills. Data structures is about how data is stored and used within computer programs, covering everything from simple containers such as variables to more complex structures such as queues, stacks and graphs. Algorithms focus on common algorithms used to traverse, search and sort data, as well as how they can be optimized. The theory of computation looks at everything to do with developing and classifying algorithms, as well as understanding what a computer can and cannot do. Data representation develops students' understanding of binary and how it is used to represent different types of data. Computer systems focuses on the different software used in computers. It also covers how logic circuits and expressions can be simplified. Computer organisation and architecture looks at the different hardware components, including a detailed focus on the processor and how assembly language works. Consequences of uses of computing considers the various issues relating to the subject and the responsibilities that computer scientists have. Communication and networking looks at how computers transmit and receive data, the structure of networks including the internet, and how they work. Databases provide students with an understanding of how a relational database is structured and developed, the role of SQL, and how client-server databases deal with multiple users. Big data is about how organisations process the large volumes of unstructured data that everyday transactions produce. Functional programming is an introduction to the theory behind this alternative programming paradigm where the focus is on functions performed on data values, and systematic approach to problem solving covers the skills that students require to successfully complete their NEA projects. At the end of the 2 years of study, students will be formally assessed via 3 components. There are 2 exams, Paper 1, known as the Programming one, and Paper 2, known as the Written one. In addition, students will complete an NEA project, which is the coursework element. In Paper 1, students will complete an on-screen exam that will assess their knowledge of programming and the relevant theory. The exam is 2 hours and 30 minutes in length and worth 40% of the final A-Level grade. In the exam, students will have to answer some short questions as well as developing programming scripts in response to the questions asked. As previously mentioned, we use Python as our assessment language. A key part of Paper 1 is the students' understanding of a skeleton program that they will study during Year 13. As you can see from the box on the right, this exam paper focuses on the first 4 of the 13 areas of study. In Paper 2, students will complete a written exam that will assess their knowledge of general computer science theory. Like Paper 1, this paper is also 2 hours and 30 minutes in length and worth 40% of the final A-level grade. This exam is a mixture of compulsory short answer and extended answer questions. This exam paper focuses on areas 5 to 12 of the course content. The final part is the NEA, which stands for Non-Examined Assessment. Students will spend around 50 hours working on a project of their choice to solve a problem or complete an investigation by developing a programming solution. In the past, students have chosen a variety of projects from games to information systems. In addition to being able to produce a good working solution, students are assessed on their ability to successfully manage and document the project. If you're considering studying A-level computer science, then you'll want to know what you have to do to be eligible for the course. It goes without saying that the majority of students who study A-level computer science have studied GCSE computer science too. For those students, they need to achieve a grade 6 or above in both computer science and maths. However, if you haven't studied GCSE computer science, then that doesn't necessarily prevent you from studying A-level computer science. For any students that fall into this category, you still need to achieve a grade 6 or above in maths. You will also need to demonstrate your aptitude for the subject. If you speak to me, then we can discuss how this can be completed. You might be wondering what goes well with computer science. Many students study maths or one or two of the sciences. However, there are students who study creative subjects such as art, media studies or music. In fact, any subject goes well with computer science because the problem solving and logic skills that you develop can be useful with everything. Many of our students have gone on to top universities in the UK to study a computing related degree course. For the last 2 years, students have secured places at Imperial College London, Southampton and Bristol, to name a few. Other students have gone on to study STEM-related subjects such as engineering. For those who are not sure that university is right for them, there are many organisations that offer a computing-related apprenticeship. Should you have any questions about the A-level course, then you can ask me via email. My email address is pbates@st-peters.surrey.sch.uk.